So now we have our sum and difference rule for derivatives. We're going to approach another question here. So consider the situation here. G of x equals x cubed plus 8 times x squared minus 3x. Okay, so this is a multiplication problem. Well, here's one thing that I can tell you. One thing that I can tell you for sure. Okay. Here's one thing that I can say for sure. G prime of x, turns out, cannot do this. Just take the derivative of the first thing times the derivative of the next thing. That does not work. That does not work. Okay. If you did do that, we can still do the derivative of the first times the derivative of the second, but I want to show you it's not equal to that. It's not equal to that. Okay, sorry about that. As you can see, the battery was running out. I had to plug in. So we're talking about the fact that this doesn't work. We're going to actually see this in a minute when we work out this derivative. Just so you can see, if I did do the derivative of x cubed plus 8, derivative of x cubed would just be 3x squared. Derivative of x cubed would just be 3x squared. Derivative of 8 would be 0. And you'd have 3x squared times derivative of x squared would be 2x minus 3. We'd end up getting 6x cubed minus 9x squared. Okay, we're going to actually work out the derivative of our problem here to see that it is not this. Okay, it is not this. In fact, it's not even anywhere close to all that stuff. But the important idea here, I just want to kind of spell out, is we cannot distribute derivatives across multiplication and division. Works for addition and subtraction, but it doesn't work for multiplication or division. Okay, just so you know that it does not work. What we can do here with this problem, though, is we can simply just multiply it out because it's a multiplication problem. So let's do that. So we would have x cubed times x squared would be x to the 5th. We would then have x cubed times 3x will be minus 3x to the 4th. In the middle, we'll have an 8 and an x squared. And we'll have an 8 and a 3 would be minus 24x. And then once we have it multiplied out, then we can simply just go through and use our sum and difference in our power rule. Derivative of x to the 5th, we would bring the exponent down, drop it by 1. 3x to the 4th, 3 would come out, bring the 4 down, drop the exponent by 1. And we just continue that process. 8x squared, bring the 2 down, drop the exponent by 1. And finally, 24 derivative of x would be 1. And then we just clean everything up by simplifying it. 5x to the 4th minus 12x cubed plus 16x minus 24. So that is the derivative of that original thing. That is the derivative of that original thing. So definitely not the same as distributing across derivatives across multiplication. Okay? It turns out it doesn't work that way. Now later on, a few sections from now, we will look at how to do derivatives of a multiplication problem where we have to actually go across the multiplication problem. But we're going to hold off on that for a little while for now and just focus on other things. But we will eventually get back to what we actually do, how we can actually do a multiplication problem, derivative as a multiplication problem. But even when we do that, it's going to actually, for a problem like this, it'd be better to just multiply them out. So that's coming a little bit later, but just for now, realize that we can't distribute across multiplication. Okay, we're not able to do that. There's more to that process. Okay. All right. Okay.